What is the Big Bang? In the beginning, there was nothing. Or perhaps it was everything. An infinite density, a singularity where all that exists and all that ever would exist was compressed into a point so small and yet so powerful that it defies our comprehension. The universe, as we know it, was not even a whisper in the dark. It was simply waiting. And then, as though struck by a divine command or a burst of primordial energy, that singularity expanded, inflating space and time into the vast cosmic tapestry we see today. This moment, shrouded in mystery, is what we call the Big Bang, the beginning of everything. From singularity to cosmos, the concept of the Big Bang, a term first coined with some irony, has grown into one of the most profound and revolutionary ideas in human thought. It suggests that the universe, which now stretches for billions of light years in every direction, began from a state of almost unimaginable compression and heat. At the very first instant, time as we understand it began before the Big Bang. There was no before, at least not in the sense we know. Time, space, energy, and matter, everything we are familiar with, did not exist. The birth of the universe is not just the birth of stars and planets, but the birth of reality itself. In those initial moments, less than a trillionth of a second after the expansion began, the universe was a seething mass of energy, hotter than anything we can comprehend. At this point, particles did not yet exist as we know them. But the very potential for particles, the fundamental building blocks of everything, was present. The rules that would govern physics, the constants of nature, and the forces that would shape the cosmos were being written in the chaotic swirl of expansion. This was no explosion in space. It was not the kind of bang we imagine when we think of fireworks or detonations. It was an expansion of space itself. The universe wasn't exploding into something. It was the explosion. In that rapid initial inflation, the universe began to take on the properties we recognize today, albeit in their most extreme forms. Time and space are born, perhaps the most mind-bending idea that emerges from the Big Bang. Bori is the realization that time and space themselves were created in this event. The dimensions we move through, the seconds ticking by on the clock, they all sprang into existence with the universe. This is difficult to grasp because we are used to thinking of space as a backdrop and time as an endless line stretching into the past and future. But before the Big Bang, neither of these concepts existed in the form we know. Imagine a world where time does not pass, where space is not stretched or curved. There is no distance, no duration, only the potential for these things. And then, with the Big Bang, the very fabric of space-time began to stretch. Distances formed where there were none before. Time began to flow. What we perceive as the unfolding of events, the march of seconds, minutes, and hours, was initiated by this cosmic expansion. But what caused it? Why did this singularity suddenly burst forth? In many ways, we are left in awe of a mystery. The laws of physics, as we understand them, break down when we try to peer too closely at the singularity itself. This has led some to wonder whether the question, what caused the Big Bang, is even the right question to ask. It may be that the beginning of the universe is a question beyond human comprehension, a riddle that will remain forever unsolved. But that very uncertainty, that lack of final answers, invites us to explore further. The first moments unfolding the universe, seen the moments following the Big Bang, the universe expanded rapidly in a process known as cosmic inflation. This inflation was so fast that distances between points in space stretched faster than the speed of light. However, because space itself was expanding, no laws of physics were violated. As the universe expanded, it began to cool. In that cooling, particles began to form, first quarks, Then protons, neutrons, and electrons. These fundamental building blocks, still unfathomably small and energetic, would one day form the atoms that make up everything we see around us, from the air we breathe to the stars that shine in distant galaxies. But for the first few 100,000 years, the universe remained an opaque plasma, a seething, hot soup of particles and radiation. It wasn't until the universe cooled enough for electrons to combine with protons and neutrons to form hydrogen and helium atoms that light could travel freely through space. This moment is known as the era of recombination, and it marks the point at which the universe became transparent. The light from that era is still visible today in the form of the cosmic microwave background radiation, a faint glow that permeates the universe and offers us a glimpse of the cosmos as it was nearly 14 billion years ago, the formation of stars and galaxies. Cosmic sculptures over time, the universe continued to expand and cool. Eventually, tiny fluctuations in the density of matter, which had been present since the earliest moments of the Big Bang, began to magnify. These fluctuations, caused by quantum mechanics, became the seeds of the vast structures we see in the universe today. Clumps of matter began to coalesce under the influence of gravity, forming the first stars and galaxies. The formation of stars was a monumental event. Within their fiery cores, hydrogen atoms fused together, producing helium and releasing enormous amounts of energy in the process. This nuclear fusion was not only the engine that powered stars, but also the mechanism by which heavier elements were created. Over billions of years, stars would forge the elements that would become the building blocks of planets, oceans, and life itself: carbon, oxygen, nitrogen, and iron. We are, as the physicist Carl Sagan famously said, made of star stuff. Every atom in our bodies was once inside a star. The birth of galaxies, those sprawling collections of stars, gas, dust, and dark matter, was another key milestone in the universe's evolution. These massive structures, with their spiral arms and bright cores, became the nurseries for star formation and the homes of planetary systems. Within these galaxies, the dance of matter and energy continued, eventually giving rise to the conditions that would allow life to emerge: the expanding universe. A future without end. Today, the universe continues to expand, a process first discovered by astronomer Edwin Hubble in the early 20th century. He observed that galaxies are moving away from each other, and the further they are, the faster they recede. This discovery provided strong evidence for the Big Bang theory and forever changed our understanding of the cosmos. But what does the future hold for an expanding universe? Will it continue to grow forever, its galaxies drifting further and further apart until the stars themselves fade into darkness? Or will the expansion one day slow, stop, and reverse, leading to a collapse, a big crunch that brings everything back to a singularity? Current evidence suggests that the universe will continue to expand, and in fact, that expansion is accelerating due to a mysterious force known as dark energy. This acceleration hints at a future where galaxies become increasingly isolated, stars burn out, and the universe grows cold and empty. In this bleak scenario, the universe would enter a phase known as heat death, where all energy is evenly distributed and no processes can occur. But even this final fate, as distant as it may be, is not the end of the story. The Big Bang reminds us that the universe is a place of constant change, birth, and transformation. What appears to be an ending may only be a new beginning in disguise. Just as the Big Bang emerged from a singularity, perhaps the death of one universe will give rise to another, the riddle of creation. The Big Bang and beyond. In the end, the Big Bang is not just a scientific theory. It is a profound philosophical question about the nature of existence itself. It challenges us to think beyond the limits of our perception and to confront the deepest mysteries of reality. What caused the Big Bang? What, if anything, existed before it? And what will become of the universe in the eons to come? While we may never fully unravel these questions, the search for answers continues to inspire wonder and curiosity. The Big Bang reminds us that we are part of a vast cosmic story, one that stretches back billions of years and will continue long after we are gone. And in that story, we find not just the origins of the universe, but the origins of ourselves. The Big Bang is both a scientific explanation and a cosmic mystery, a riddle that invites us to explore not just the outer reaches of space, but the very nature of existence. We may never fully understand it, but in the search for answers, we uncover the beauty and complexity of the universe and perhaps the meaning of our place within it.